G'day everyone, got a GP3500 here, it's customer's one. It's a special job he wants done, and this applies to all the GP detectors, GP Extreme, GP3000 and the GP3500. I don't think there's any other GP ones. Anyway, this one here is a hamburger with the lot. It has variable frequency put in it, and it has variable gain put in it. And I've completely stripped out the whole front end of this detector, the input stage, and I've put a big stacker in there. Now that would be, if McDonald's were selling that, they would call that the big stack. Um, yeah, anyway, that's complete new front end and variable gain all in a big stack of circuit boards there. I've beefed up the power supplies, and it's been wired up to configure all the other stuff we've put in it. So I'll put that down. But before I show you what this can do, we'll have to examine the history of these detectors and why people upgraded or bought the new ones. First of all these detectors, the GP series, they all use normal timings, and in the case of normal timings, they use three short pulses and one long pulse, and they're all basically the same, the way they transmit. And that pulse configuration, it's like a jack of all trades pulse. It'll tickle big targets at depth, and it also works pretty well with small targets as well. Where it could be a little bit lacking if you start looking for targets that are just, tiny half pinheads or something like that. But these detectors are really good at finding big, deep gold. Now, with the normal mode of timings, that's the three small and one long, they had it's not really, it's hard, it's going to be interesting to explain this, but I'll explain it the best I can. Everyone thought they were very susceptible to generating ground noise signals. So people were digging up conductive clay and charcoal, all sorts of things. And is it really a flaw of the detector that it was actually picking up that stuff? Because in the later models, they still have normal timings, and if you use them, they'll still pick up the same clay, and they'll still pick up the same charcoal, right? But these don't have the fine timings, the fine gold, and also the enhanced mode. Now, with those other modes in the newer detectors, they generate smaller, sharper pulses, and they do remove a lot of the ground noise. Well, not the ground noise, but I'm talking more like the sort of longer, iffy, stretched out signals you get from conductive clay, stuff like that. You don't get a short, sharp signal from these conductive clays. I never found one, unless it's a hot rock, and that's no clay, is it? But normally, you go over it and you go, oh, is it a big target deep or is it a clay dome? The biggest giveaway on those targets is if you're using a small coil, right, and you get this whoa, sort of groany sort of a sound. And you'd think to yourself, is that a big deep target or is that clay? Well, could be either. But there's one thing. When you're looking for big gold, why are you using a small coil? If you use a big coil, right, it's the way this clay stuff works. It's not usually deep, and if it is, the signal dies off. You'll never hear it. It's usually close to the surface and it's very concentrated. It may only be 12 inches across as a maximum. I've never found anything. I myself have never found anything bigger than that. But you got a small coil, and 11, 12, 13, 14, 15, 16, even up to 18, I'd say. You could go into the 20, but if you go over something like that and it's just a couple of inches under the ground, it's going to cause this warbly, groany type signal. And the smaller the coil you've got, the worse it is. And what I used to do when I was using the GPX, of all things, I'll go into the GPX because we had a mode on it we could flick. And what I usually did is I flicked it in. This is only for small. I'm not looking for big, deep gold. I've got a relatively small coil. I get one of these targets. I'd stick it in to enhance, and more often than not, the target signal would go away. So I said, "Oh, that's just conductive clay." So I won't dig it. Okay, this gets even more peculiar. All right, there's a fellow I know who had a signal like that, a groany ground noise signal. This fellow, I'm not going to say too much. He lives in Denali. Well, he did. I haven't seen him for years. And I think it was over at German Hill, German Gully. And the story goes something along this line. Oh, it's a ground noise. Yeah, yeah. Nah, it's a ground noise. Does the whole thing, sweeps it, um, east, west, north, south, does all the normal thing that you would do to discern if it was a real target or not. This guy's a very, very, very highly regarded professional prospector. He does it all the time. Yeah, like I say, I haven't heard from him for many years, so I don't know if he's still doing it. But this would have probably been with a 3000 or a detector around that era. And he ignored it and he went on his merry way detecting. And this is getting a bit rusty on me because it was so many years ago I was told this, that something was niggling him about that target or something. And he went back to this ground noise and he dug it because it'd been a while and he just thought, well, I'm going to dig it, get it out of my head. And it turned out to be a 13-ounce nugget. So yeah, there's a lot to be said for ignoring ground noises. But I digress a little bit. When you have a detector set up for big, deep gold and you're using a big coil. Now, like I was doing in the previous videos about the drag coils, right? The bigger the coil, the deeper it's going to go, and it's going to absolutely diminish the return of ground noise and ground signals, like those conductive clay things. They just will not energize or give a return signal of too much amplitude that it's going to pull you up and you're going to stop and dig it. They're greatly reduced. But with a bit of practice and you stuck using one of these detectors, yeah, you can get fairly accurate with, yeah, I'm pretty sure it's a ground noise, and 90% of the time you'll probably be right. But that 10% of the time you'll be wrong. So what are you going to walk over? So that's why a lot of people, they thought with these detectors, well, we'll get rid of the ground noise, we won't dig any more hot targets. So they went and bought the new detectors and they ran around in enhanced mode, right? I know so many prospectors that just go around in enhanced mode and all they pick up is the fly dung, right? They pick up fly dung. There has been exceptions, of course. There's exceptions to everything, but enhanced mode does not go anywhere as deep as normal mode on a big target. It just has not got the oomph in the pulses to energize that target fully, so you get a good return signal. So that's what I'm saying with these detectors, right? Now, this is where it gets into the nitty-gritty of it. What was the biggest problem with the GP series detectors? I'll tell you right now what it was. No gain control. You had fixed high-level gain for every situation you encountered. Now, obviously, you're going to get into high ironstone areas, or you're going to have that really mineralized clay. It's going to overload the poor detector. It's going to be swamping the front end, and it's going to cause false signals galore. But what about if you could turn the gain down? Now, people think, I'll turn the gain from where I normally use it. I'll turn it down half. If I do that, I'll get half the signals. No, you won't. You'll get about 95% of the signals, maybe more, right? Turning the gain down, right, increases the dynamic range of your input stage. It can sort out the signals better. They don't, all intermod and make a big jumble of mess for the poor thing to try and work out what's what. Sometimes dumbing it down a little bit has a massive advantage in hearing those big, deep signals that are very, very hard to detect. So, if it wasn't a thing, well, then why do all the new detectors have gain control? I think it's pretty obvious, isn't it? But these don't. But we can put it in. Now, there's people out there who are putting a dual gang potentiometer onto the detector and run some wires, add some resistors, right? Now I'm going to explain this to you why you do not do this, and just put it across the feedback. The output and the non-inverting inputs on the front end of these, or any detector. It's the biggest no-no there is. Because if it was so damn simple and it would work so well, why didn't Minelab do it on all these? Why haven't they got gain control? It's not as easy as you think to do, to have dual tracking gain control. And I'll explain why. These have two input channels, two complete input channels, right? And the way they work, you need two to run these in cancel mode for a start. And in double D mode, it uses one of the op amp channels. Okay, so it can be a little bit haywire. You can be a little bit flimsy, right? Or it can be a little bit out of tolerance. It's going to work, but in mono mode, it uses both, right? And when you're running both, everything has to be exact, right? So if you put have a look at the feedback resistors on these. They're 0.1% resistors, right? 0.1%. Why do they have to be so accurate? Because when you have two channels going at the same time, which connects onto the monocoil, an imbalance is going to upset the ground balance. It's going to upset the signal recovery, right? It may work okay on fly specs close to the ground, right? But when you're talking big, deep targets, that's going to throw the detector out of balance and it's not going to work properly. You may walk over gold, even intermediate depth gold. So what you have to do is when you, you've got to have them accurate, put it that way, right? We're talking 0.1% accuracy for the both input channels. You get a dual gang potentiometer and you say, oh, I'll use one gang on that potentiometer for one channel and the other gang for the other. And I'll tell you right now, potentiometers have up to 20% error between each gang in the potentiometer. You might think that they're rotating equally. It's not. The layering of carbon cannot be done accurately enough that on this one, it's the same here. It doesn't happen. Get any potentiometer, get a couple of multimeters or even just a single multimeter, turn it halfway, and on one connection to the middle, measure the resistance, and on the other, measure the resistance. I'll put $1 million on it. It will not be the same, right? It will not be the same. Doesn't work that way. On these ones we use a gain chip, right? Which is accurate, fairly accurate. What's it accurate to? I think it's, I'm trying to remember, it's a long time since I actually designed the gain board on this, but it's, it's probably accurate to a 1.5 decibels or something within. It's a very small amount. But what that does, it connects to a single gang potentiometer on the board, but that potentiometer controls 2 channels equally. It has laser trimmed stepped resistors in the ladder network that controls the gain of the chip. It's none of this, oh, it might be there, it might be there, it might be here, whatever, as you go up. It tracks. It's perfectly symmetrical. And that's how we do ours. So everything we do, we use 0.1% metal film resistors. We do not use noisy carbon film resistors for the most critical part of the detector. You probably also notice that on the original Minelab designs, they use tubular resistors, right? And all the rest of it's flat resistors, just standard 0805s or 0402s or whatever it is. And on the low noise componentry parts of these detectors, they use special devices because I'll show you what they are. I'll grab one detector here. No, I can't grab that one. That's got too much secret sauce hanging off it. How about this this scrappy old board? No, it's too scrappy. I want to find one that hang on a second. Yep, I've got one over here I can grab. This is another one that's come in for upgrades, but it hasn't been, it's yet to be touched. But I'll just point out the low noise components. Like all these standard flat components, right? They're probably 5% tolerance. But if you have a look at the front end part of the detector here, you can see those tubular looking resistors. They're not done for power or anything like that, even though they do have a better power rating, right? They're called MELF, M-E-L-F resistors. And the reason they are like this is because they are low noise resistors and they're 0.1% accurate. So they set the gain of your input stage. 2 for one channel, 2 for the other, and they are identical. When you have a look around here, there's 2 more there. They are low noise resistors, and I think there's another one up here, low noise resistor as well. But most of the resistors that are critical are metal film resistors, and you can also get the standard 0805s and any other size 0603s or whatever size there is. You can get them in 0.1% metal film. The thing about these resistors, these tubular ones, is that if you buy these things at that accuracy, the higher the accuracy, the more pricey they are. Those resistors there could cost $2 each, right? Whereas a standard resistor over here, like these small things, if they're just standard composition resistors and they're 5%, they'll be costing, I don't know, 2 for a cent, or probably that's in bulk, but it's sort of like 2 to 5 cents each in relatively small quantities. So the accuracy on these detectors, Minelab didn't do this for fun, right? That's why I'm saying don't go sticking 20% inaccurate potentiometers into a detector, wire it into the front end, say, oh, look, it's variable gain. It's not. It is, but it's not, right? It's like using a transistor radio as a hi-fi. It's not going to work very well. And it irks me when I've heard people, right, tell me, oh, someone else does what you do, and they tell us it's exactly the same as you do, but we do it cheaper. And I said, I bet you do it cheaper too. You know, clueless, clueless. You know, like the fellow who used to ring me up all the time saying, oh, how do I do this? How do I do that? And stupid me was giving him a lot of information to start with. And then I saw the ad go in the back of the Gold, Gem and Treasure, right? And he said he was only doing it for himself. And I just went, oh, yeah. So, and I'll have to add this. This is a beauty, what he told people. I used to get the people ring me up and tell me. I get told everything. Anyone says anything bad, right? It comes back and I find out who said it. So, yeah, it's a particular, like I say, it's a particular shop over in WA. Needs to shut their mouth too. Just spreading crap at customers' expense just to sell a detector. Oh dear me, it really gets me because it's all untruths. There's tons of it. But yeah, the other one, this one's on the East Coast. How'd it go? Oh, this guy taught me everything I know. Taught me everything I know. Right? Was the exact words I got told. Oh, I nearly fell off my chair. I said, really? I said, God, So if he's talking about detectors, I must have known him since 1980. No, 1990. Mid 1990s, possibly. So he's missed out on 15 years worth of knowledge there. But it just pisses me off. It's ridiculous. Sorry, I'm going off on a bit of a tangent there, but yeah, I do have the feedback from people, and they do tell me what is said. And thank you for everyone who tells me, by the way. Yeah, it's good to know. It doesn't really affect anything, but I like having a counter to their crap they pump out. I really hate it to a degree. I don't dwell on it, but when you hear it, you just cringe and go, oh, why are you saying such things? I don't go around saying, oh, so and so, the detector seller is a this, that, this, and the other, or all the other ones into debt for Minelab for $1 million, and the only reason Minelab keeps him on the books is because he owes that much money and they can't afford to lose it. I don't go around saying stuff like that. I don't make up stuff like that. But yeah, that's speculation, by the way. It's not real. It could be, couldn't it? But it's probably speculation. So yeah, I hear a lot of stuff. I really hear a lot of stuff. And you probably know that, there's been dealers out there that are no longer dealers and stuff. I get told the stories on that. If it's true or not, I don't know. I'm not going to go and repeat it. But some of it's funny. It makes me laugh. It's like a person here, or I won't say here, person who was selling detectors for many years and never paid any tax and got caught. Yeah, you hear all this stuff and you just go, that's amazing. It really is. I hear stuff about certain companies doing things for another company because the other company's products are failing. I know all this, but I'm not going to go and say anything about it. People can work it out themselves. Anyway, I was going to turn this on. God, I waffled on. Must be bored. Well, actually, I'm trapped in my room at the moment because everyone's got COVID here. We did COVID tests and they all came up positive. And the only person who hasn't got it is me. And I've been with everybody, mingle, 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 and I've been with previous COVID cases, mingle, mingle, mingle. I never get it. I do not catch this COVID thing. I don't know why. But me saying that, I'll probably catch it. Murphy's Law. Anyway, we'll turn this on. I'll show you what it does. Okay. Batteries in my little amplifier here are a bit on the low side, so it might go into distortion if I make a big loud noise. But this is running very quietly at the moment. It's running through, just doing that. I'm pumping air through it and just moving air. Yeah, it changes various values in componentry, and they change, and it'll actually make the detector make that noise. So lucky when you're using them, they're all sealed up in a box, so it doesn't move. So if you wave air near it, I'll turn it up a bit louder. Like, there you go, just a bit of air. That's how sensitive they are, and that's why you have to use 0.1% resistors and 2% capacitors, right, on these. Anything that's doing the same thing. You have a look here, all these chopper amplifiers, right? All that'll be very accurate, probably 0.1% metal films along there. Anyway, I've got this. I don't want to use the 0.1. I want to use that, the 0.05, the specky thing on the end there. We'll turn around to the coil. I'll show you what this old detector does with a bit of TLC and upgrading. So you don't think you can use these as a very efficient small gold detector? Interesting. What happens if I turn the gain up on it? Which way do I go for gain on this? Yeah. You hear that? That's my amplifier. The battery voltage dipped too far and it made that noise. I'm getting way up the shaft here, right? Way up on a 0.05. Okay? And listen how quiet it is. I don't want to overload my amplifier because the batteries aren't going to hold the voltage up. So that's a 0.1. It's further up the stick. But you remember even GPX's standard, you can only pick that up in normal mode, what, a couple of millimeter, 5mm or so off the top of the coil. So the old detectors can be made to work brilliantly, and this would be a killer on big deep gold. Absolutely killer on it, because I'll show you. I'm going to turn this around. I'll do it slowly so no one gets car sick. Right? I'll face it back down. I've actually got this running off my supply over there because this battery's not charged. I don't like shouldn't do that to lithium, like what I'm doing, because it'll wreck the lithium battery. But I'll turn that off. I'll disconnect here. Now, it's upside down. This had old clock pots on it. Something we did a long time ago, and I wish I never did it, because the pots were inductive resistors, and they're actually not inside the pot on the other side of the shielding. Unknown to me, they're in the front part of the control. And what do you think happened? Picked up the bloody impulses from the coil. So either I had to put paddock capacitors or filter capacitors on the back of all the pots to stop it doing that, or rip them out and go back to using Alps pots, which are one of the best potentiometers in the world. I use Alps pots. They're Japanese, beautiful potentiometers, good for millions of turns. So, and they got a little mark in the top there, if you can see it, so you know where you're going. You know, basically, people say, "Oh, we put numbers on our pots," and why do you detect by numbers? Got me. No, listen to the ground balance, see where you're going to put it so it matches the ground. Don't say, "Oh, number 4 will do today," or "number 5 will do tomorrow." That's totally stupid. Don't do stuff like that. Always adjust for the ground you're working, because each area has different ground. Yeah, so the front of the detector anyway looks the same as any standard detector. You got tracking and fixed, slow. This is your tracking speed. Fast, medium, slow. On these, I've always used it in slow. Double D, mono, cancel. You got all metal. I always just leave it click in all metal, and that's your manual tuning. You can use that as a fine tune. You don't really need to, because on the front here, you've got frequency. Sorry, this one. This is your frequency. So you can lower the frequency way down, big coil, deep gold, and literally, really, I'm not going to say literally, everyone says that word, I hate it. And you can really tune out birdshot and stuff like that if you don't want to stop on the tiny stuff. You want to optimize it with a big coil deep, just put the frequency down. The other thing too, when we do the frequency, variable frequency in these, it's not stepped, it's not just 1, 2, or 3 or 4 positions. It's continually variable, right? So you can make the finest little adjustment. It's no problem at all, but you've got a massive spread. I can't remember what it is off the top of my head, but it's somewhere. It might be getting on 10 microseconds of time difference across the spectrum, but it really pings on small stuff when it's cranked all the way up, and when you crank it all the way down, you can basically make it put out larger pulses for bigger, deeper gold using bigger coils, or you just put it in the middle. See a little mark in the middle there, if you can see it. I don't know if you can, but there's a sort of like a notch in the middle of these, and just have it straight up and down, and that's about midpoint on the gain. So if you say, "Oh, I just want Minelab settings, midpoint," it's basically the same as a standard Minelab detector in that setup, but then you can optimize gain and frequency. The other thing to note too, I should say this, because these detectors have a thing in them, which is in the oscillator stage, it actually has a phase lock loop. Always start the detector in the highest frequency. Turn it all the way up, turn the detector on, let it run for 5 seconds. Then you can move this wherever you want, right? That's one thing to remember with this particular modification. If you start it in the low frequency, right, and then you take the frequency up, it'll go into mumble mode because the phase lock loop goes out of whack and it can't lock anymore. I actually probably could fix that, but I haven't looked at it exactly, the mechanism of why it does that. But if you start at the highest frequency, it's no problem. Just bang it down wherever. And if you do start it in the wrong position, you'll soon know. Turn the detector off, turn that float out, turn it back on, then adjust it to wherever you want. So that's one little thing. Now the gain. We're getting onto the gain. Now we've got gain like all the modern detectors. Now, okay, we're working really hot ironstone. Well, that's really reactive, really noisy. Good, I can reduce the gain. I've got more headroom now. Now I can discern targets, proper targets over groany ground and all sorts of hot rocks, they'll sound different. You're not banging the poor dynamic range up against the top limits. It's you're going to have range there. It's not just like this. It doesn't do that noise. I just do that for effect, but it's pushing up against the wall. You can have the gain all the way down, and you can work around like a sheet of corrugated iron. Not really, but I'm just emphasizing that it will handle whatever you throw at it, right? So, if you've got really mild ground, like you're in pipe clays or non-reactive type ground out in the deserts or out the back of Burke or wherever it may be, crank the gain up. You've got a lot more gain than the standard Minelab too. So, um, horses for courses. You run a cancel coil, big, huge cancel coil. Turn the gain all the way up, and you won't get any interference. It'll cut out all the terrestrial noise. You'll get rid of the sun noise. You'll get rid of satellite noise. You get rid of aeroplane noise. You get rid of HF radio, AM radio, TV, translators, FM stations, you name it. It will not affect it if you run cancel mode. Power lines too. It cancels it all out. So this is why these detectors are done, and the guys who get these done use drag coils, right? And I tell you what, it's like a secret society. You don't hear hardly anything from anybody about the grunted up detectors. We do hundreds of these things, and you don't hear about it, And they always have a cover over it, and they have flaps over it. And you can't see in their detector. They won't let anyone know. It's absolutely top secret stuff. It's amazing. Your detecting mates will probably tell you, but you bump into people, they're not going to say anything. I've actually gone out with people. We've done upgrades, and I had to do some training for some of them years ago at Denali, and they made flaps, little canvas flaps that went over their detector, so no one could see the extra controls. So I thought that was quite amusing. So that's that. I hope I've educated some of you about these older detectors. There is nothing wrong with the older detectors. You can make these into an absolute super deep gold finding machine. And you also notice there, it's really, really good on the small stuff. That's outperforming the newer detectors. Not a problem. Easy. I'll do a side by side any day on that. A lot less a lot less noise. God, I'm getting tongue tied again. Yeah, and it's very, very low noise, and you got huge amounts of amplification there, massive range on frequency, massive range on gain, and that's it. That's that beast. So we can do that to any of the older detectors. We can even do it on, we do this stuff on SD2000s for people. I don't like doing it because I've got to shut their noisy power supply up because otherwise it just swamps the front end. So it's a bit more work in doing those, but we've got these configurations. We can get it into any of the detectors. The only ones it won't go into is where they put the stopgap measure by putting the sealed modules inside the detector and handshake things for chips for coils and things. That's locking us out. We can't do anything on those. Well, I got a good 10 to 15% out of 7,000, so I've been told. So, and that was just doing some stuff what I would think of being, for me, fairly straightforward. I don't know, why I can find this stuff and fix it and other people can't. Don't know. No idea. But yeah, like I say, I've been doing it for years and years and years. Done a lot in HF radio, done a lot on satellite systems. I've built satellite receivers, built satellite preamplifiers, done a whole heap of weird stuff over the years. Lot of strange, weird stuff. Especially in radio communications and microwave transmitters, receivers, and stuff like that. I used to make microwave amplifiers for the TV stations for their OB vans years ago. Um, you know, slowly got out of all that sort of stuff, and detectors have been taking up most of my time. So yeah, that's where we are. Anyway, that's a bit of an education, I think, because it's really hard to get any information on these detectors. You know, there's not a you're not going to buy a book on this and say, oh, this is how this works. You won't find it. No one wants you to know how it works. That's why they grind all the numbers off the chips. You're not allowed to know, and you know, it's taken a fair bit of time to work out what all the numbers of the chips are, and that's on all their detectors, except for the newer ones. I leave the numbers there because it's all done in the field programmable chips, and yeah, with the ball grid array type things and whatever else they are, they're not going to get hacked. They're not going to get looked at, and it's to stop the people from that country up north, making clones. That's basically why it's done in a high tech way, I suppose. Like I say, I don't know. I just speculate. It's an opinion. Opinions are protected by the Hague Conventions, so it's my opinion. You can't go someone for having an opinion. Anyway, it's probably enough waffle, and yeah, I'll chop those wires off and I'll stick it back in its box and send it back to where it belongs, back to the customer. Catch us later.